All right. So I want to finish up here with this solving systems of equation stuff with a couple examples. So we've talked about systems of two equations, right? When it comes to having three variables, two equations just isn't enough to get a unique solution. So let's say we have three equations, right? Three equations of planes. I want you to think about what could happen there in terms of solutions. Okay? So one situation that could happen is that the three planes sort of don't all align right and they sort of bound off some kind of region and just have no solution, right? There's no place where they all intersect. Right? So that's always a possibility. It's always a possibility that all three of them are the same plane. But let's ignore those two. Let's think about what else could happen. Let's say they all intersect. And there's places where they all intersect at the where all three planes intersect. Well, what we're going to have is one of the two following situations. Let me show you them graphically. All right, let me start with the second one here, actually. All right, one situation we could have is this, where all three planes cross in a line like this. This is a pretty rare situation to happen. All right, just like it's not as rare as them all being the same plane, but it's a lot more rare than the other situation we're going to show. All right, so here's a situation where they all intersect in a line. What else could happen? Well, this. So what has happened here? Let's zoom in on this picture a bit. If you look right here, there's a point where all three of them cross. And if you look at it, there's no other point where all three hit. All right? So what's sort of happening here is if you take any two of these planes, you get a pair of lines, and this point right here is the place where those two lines cross. Right? If you take all of the pairwise intersections, you get three lines. The line from the blue and orange one, the line from the blue and green one, and the line from the green and orange one. And they all intersect in this one spot. So the solution to this system should be 1 point. All right? So let's look at this. Let me copy down here the system of equations. Let me switch over here. All right, so the system of equations is x minus y minus z equals 0. X plus 2y minus z equals 6. And 2x minus z equals 5. Okay? So this is equations 1, 2, and 3. All right? So, how do we solve for that point? Well, we can do what we've kind of been doing earlier, but I want to solve this in a particular way. Right? There's a particular way I want to solve this because it's going to be the foundation for an algorithm for how we can solve any of these systems. Right? So, alright, it's honestly bugging me just a tad that this is low. Let's move that up. Alright. So, what is this algorithm here that we want to use? Well, what we're going to do is we're going to start by making sure the first equation has an x by itself here. Right? So this already has it. The next step is going to be getting rid of these. So what we're going to look at here is we're going to look at equation 2, and we're going to subtract equation 1 from that. We have x plus 2y minus z equals 6, and x minus y minus z equals 0. Alright, so subtract these. So we get 3y equals 6. Okay? So what I'm going to do is I'm going to rewrite this system here, and I'm going to... Equation 2 is the one I want to change here. So what I'm going to do is I'm going to take equation 2 and I'm going to replace it with this one. Right? So we have x minus y minus z equals 0. Here we get 3y, 3y equals 6, and 2x minus z equals 5. Okay, so that's a start. Now, before you jump ahead and solve for y there, I want you to follow this algorithm. Okay? So again, I'm still going to refer to these as 1, 2, and 3. Okay? So the next step we're going to do is we want to get rid of this 2x here. Okay? So to do that, we're going to do equation 3 minus 2 times equation 1. Alright, so let's see, equation 3 is 2x minus z equals 5. Alright, 2 times equation 1 is 2x minus 2y minus 2z equals 0. Alright, now we subtract these. So 0, this gives us a 2y. Subtract these and we have plus z. And this is 5. Right? Now again, I'm going to replace equation 3 with this one I just found. Alright, let's see here. So the first equation doesn't change. 3y equals 6, and 2y plus z equals 5. Okay, so I'm going to stop writing the 1, 2, 3. I think you guys get the point of this by now. So now that we have a single x here and nothing below it, now let's focus on the y. So we're going to move to the second equation, look at the y here, and what we want to do is make this just be a single y. Just like we have the single x here, we want this to be a single y. So what we're going to do is... I'm going to take 1/3 of row 2, of equation 2. Alright? So that's x minus y minus z equals 0. Y equals 2. Make sure that that's a 0 there. And 2y plus z equals 5. Okay? So I'm going to start leaving off these computations. I'm not going to write them out. But we'll just sort of talk about what's going to go on in the next steps, and I'll let you verify it. Okay? Alright, so our next step is to get rid of these two y's. Right? We got the one in the second row that we want. We need to get rid of these. So here's what we're going to do. We're going to take our equation 1, and we're going to add equation 2, and I'm going to replace equation 1 with that. Alright? If we do that, so we're adding equations 1 and 2. So we have x, the y's cancel, minus z equals 0, y equals 2, and 2y plus z equals 5. Now we're going to do a very similar thing here. We're going to get rid of this 2y, and the way we're going to do that is we're going to take equation 3, and we're going to subtract twice equation 2, and replace equation 3 with it. Okay? So this is x minus z equals 0, y equals 2, and here we're just going to have z equals 1 left over. Alright? Now maybe you can see now why we're doing it this way. But let's finish this up. There's one more step. It's equation 1 plus equation 3, and we're going to replace equation 1 with that. Right, so we have x equals 1, y equals 2, z equals 1. Okay? Can you see why we went through that algorithm? Can you see what happens with this solution here? Well, hopefully you can. The solution x, y, z is right in our face. X is 1, y is 2, z is 1. Right? It's right there in our face. Right? So, we'll leave it here for now. But what I want to say is this process we just went through, right? This is what we call Gaussian elimination. Gaussian elimination. Right? In fact, this is even more than Gaussian. This is what we call Gauss-Jordan. So I actually took it a step further than I originally intended to. But that's okay. We'll talk about both of these in the future. So hopefully this makes sense. And yeah. Take care.